energy needed to walk varies in a predictable way with the size of the animal. But nature has come up with one or two surprises. When caribou walk, they use far less energy than predicted by our equations. And when they move from hard ground to soft snow, the energy they use hardly increases. It's not entirely clear how they perform this trick, though their hooves certainly play a part. They're only loosely attached by ligaments, and so can splay out like snowshoes when pressed onto the ground. But the real secret of their success must lie in making each swing of their legs as economic as possible. The caribou's extreme energy efficiency has been shaped by their need to make long treks over snowy landscapes. Each year, they move from more sheltered areas in the south, where they spend the winter, to more exposed coastal slopes, where the females will give birth. Here, the grazing is better, and they should find some respite from uncountable swarms of biting insects. But no one's yet braving these remote, mosquito-infested regions to work on a robo-caribou. Especially when there's more than enough inspiration much closer to home. Our own bodies have also been shaped by natural selection to produce our unique two-legged gait. Engineers at Honda in Japan have made detailed studies of the human leg as they've evolved their own bipedal robot, Asimo. The positioning and flexibility of the joints in Asimo's legs have been carefully modeled on those of humans, giving Asimo a very human-like movement. But walking on two legs, rather than 4 or 6, is inherently unstable. We've solved this problem by having sophisticated balance organs in our ears, which, working with sensors that tell us the position and angle of our joints, produce some truly remarkable results. Asimo's designers have copied this system and given it a range of joint and limb sensors, which means Asimo can walk, run, turn, and even climb stairs extremely well. Asimo uses a lot of energy to achieve its amazing performance, but it's possible to make a bipedal robot with the energy-efficient leg swing of a caribou. This robot has no power supply and no sophisticated control systems, but it can walk down a slope and coordinates its legs to avoid falling over. Give it a power supply and you've got Denise. All that this robot has is a sensor on the bottom of each foot. When one foot hits the ground, that tells the other one to kick off. Most of the energy to move forward comes from the pendulum-like swinging of the leg, just like a caribou. Denise uses only about 1/10 of the power of Asimo, and she's an empty-headed robot. All her coordination takes place without a central computer. In some ways, more like an insect. Asimo is the exact opposite. All its complex abilities are controlled by a wireless link from a powerful computer. This is a very different approach from those studying the simple, localized controllers of insects. Asimo needs a complicated central controller. There's a model for this in nature, the human brain. But no one has yet come close to really understanding how that does what it does. way of seeing the world, bio-inspiration is full of promise for new technology. But it's also a new way of seeing nature and of appreciating the vast complexity of life. But the real joy of this new view is that inspiration can come from anywhere, from the lowliest creatures that we might just swat to our own bodies. Nature is the biggest research library on the planet. It's just a question of knowing how to read it. In the next program, we see how, using nature's designs, we can manufacture advanced, intelligent materials and develop elegant and unexpected methods of building.